Before we get to the final lesson for the unit, I just want to go over another one of your calculator functions that you are responsible for remembering. One of the annoying parts of working with repetitive substitution is whenever you have to keep typing values in over and over, especially as these equations get longer and longer. What I'm going to show you here is a way to recall your last entry and simply change the space. Now this is a beginning level introduction. I'm not going to show you all the tough parts of it, but for those of you who aren't afraid to try to program computers and try to do things, there actually is another thing I'm going to show you. If you look above the delete button, you see INS, and that is something I'll be showing you how to use a little bit. It's called insert. It's whenever you want to actually insert something into a space. But other than that, for now, let's just focus on learning and remember how the recall works, and then you can add this to your understanding and use it later. We know that one of the things we have to do is create a table of values, and so we understand also that whenever we create a table of values, we are supposed to take X and Y and do this. Now some of you who have been graphing these things over the last week have not been doing the table, and what I have said to you is that if you actually, I think it was already on the quiz, but last week if you didn't do that, you lost credit. On this test it's going to be the same thing. So whenever you see the thing that says create the table, make sure you create a table with those numbers. But again, what we know is that when we type this in, we are supposed to type negative, and our fraction goes in parentheses. Excuse me. That anytime we change a letter, we use parentheses, so we put our -2 in there, and then plus 6, and that gives us 6.6. Actually, it's not supposed to be -2, is it? This is actually supposed to be, because I'm counting by threes, -3, -6, 3, and 6. That was something that we talked about before that I forgot to do myself. But anyway, negative parentheses 1/3 times -6 plus 6 gives us the answer of 8, which is a nice number that we could plot. But the thing about what we did not know before was that we'd have to type this all over again and put the -3 in there. What you can do is you can press second and enter, and what that does for you, if you notice, is it recalls the old information and puts our cursor right here, which means all we have to do now is go back to the -6 and turn it into a 3. Simply type a 3 over its space. The way our keyboard works, it simply replaces a space, which is why I said I have to kind of show you something to augment this, but right now it just saved us time of having to type all that in. I hit enter. I find out that this is 7. Same thing, I go here, I hit second enter, your screen pulls it up. What I can do now, because I don't want this negative, is I can highlight over the negative and delete it, hitting the DEL button, and then turn 3 into a 0, and that gives me my next number. I can then again second enter to recall it, go back to the 1 to make it, or 0 to make it a 3, which gives me my next answer, and then same thing, second enter, go back to the number that you want to change, turn that into a 6, which gives me my last answer. So again, use this to your advantage, especially whenever you have a whole lot of things to enter. A lot of us, whenever we type things in, we tend to make small mistakes. Like I've had kids who forgot to type in the negative on the numbers and just other crazy things. So again, use that to your advantage. Chapter 4, Section 7 represents the last section. It's the best news is that we've already seen the process necessary that we need to do. There are two main types of sequences. The first is arithmetic, the second is geometric. We've seen a few geometric series in class, but today we're going to focus on the arithmetic part. Arithmetic series is a series in which the same amount is being added or subtracted. So again, it's not the multiplication division, but it's whenever it's added or subtracted. We know this as linear functions because what we learned is that whenever it's linear, it has the same common difference after your first check, and that is pretty much what an arithmetic series is. Our jobs are simple. First, we are asked to identify whether it's arithmetic. Second, we're asked to create a function rule to represent it. Again, both of these processes were covered 2 weeks ago, and they should be within our skill set. So let's look at a few examples here before we close out this video. So again, the first thing it's going to say is determine whether it's arithmetic, and if it is, write a function rule to represent it. The only difference between the arithmetic series and what we're used to is that they do not give us two numbers. They simply say 5 goes to 7, goes to 9, goes to 11. But we do the same thing as before. We recognize that this is adding 2, that this is adding 2, and that this is adding 2. So the answer to whether it's arithmetic is yes. But keep in mind, what we learned in our series work is that whenever the common difference on the first attempt works, that is our rate of change, and so we should put 2x. Also keep in mind that what we want to do is list those numbers. Now the thing about arithmetic series is that you consider this the first, second, third, and fourth entry, and so that actually has a value of 1, 2, 3, and 4. So what you want to do is plug in 1 for that to recognize that you should get 2, 4, 6, and 8. And so when you look at the actual series, for those of you who like to do it this way because it does work, what we actually have is the first being 5, the second being 7, 9, and 11. And when we look at this series, all we are doing is adding 3. And so the series pattern should be 2x plus 3, or the way they will write it is a sub n equals 2n plus 3. What they mean is the arithmetic series of whatever the term is equal to 2 times the term plus 3. So if they ask you what the 11th term is, then that means you want the 11th term, which means put an 11 in here, which is 22 plus 3, which would be 25. And so you'd be able to say that the 11th term is 25 based off of that information. But again, the general idea is once that common difference is there, that is your rate of change like it was last week, 2 weeks ago. And that all you have to do is adjust your number, or make your adjustment number to fit 1, 2, 3, 4 terms. Looking at the second one, again, this is plus 3, plus 6. Once they don't match, the answer is no, and they really don't need a rule to represent it if it's not arithmetic. We're not going to go through that. We went through that already. But again, once that common difference is not the same, it's not linear, which means it's not arithmetic, move on. Here, from -5 to -1, remember that -1 is bigger than -5, which means we are actually adding 4. From -1 to 3, 1 step takes me to 0, 3 more steps takes me to 3. Again, that's adding 4. This is adding 4, which means that I should have a 4x base for this pattern. Then again, you want to list. This is first, second, third, and fourth. Based off of this, the first should be 4, 8, 12, 16. I now have -5, -1, 3, and 7. And so the easiest thing for me to do is to pick numbers that make sense to me, because I know I'm going to probably be adding or subtracting here. From 12 to 3, I subtract 9. I think 8 minus 9 is -1, which it is, and I think 4 minus 9 is -5, which it is. 16 minus 9 is definitely 7. So we know that we're going to subtract 9, which means that our rule is 4x minus 9. And again, if you wrote that, I'd be fine if you put y equals 4x minus 9, but the formal way they do it is a of n is 4n minus 9 when you go to your computer program. But again, it's not tough, not anything really bad. It's just you have to make sure you know how to do that stuff. And again, the good news is you already know how to do it. You just have to adjust your understanding for what's going on. Here, to get from 1 to -11, I think this is bad. I think I messed up. I think it's supposed to be -1. But anyway, from -1 to -11, you subtract 10. From -11 to -21, you subtract 10. Subtract 10. That means in my base, because the common difference in the first try was -10, is -10x. The next thing I do is list what should be there, and based off of the first, second, third, and fourth, if this was a series, it should be -10, -20, -30, -40. Instead, I have -1, -11, -21, and -31. Again, this is getting bigger from 10 to 1, which means I definitely know I'm adding. But to get from -10 to -1, I think I am adding 9. So let's check it. -10 plus 9 is -1. -20 plus 9 is your -11. -30 plus 9 gives me enough evidence right there to see that I'm getting what I need to. And so my pattern is this plus 9. Again, if you wrote that, you'd be fine, but the official answer is a of n equals -10n plus 9. So again, the good news was you already knew how to do this. Hopefully you have that skill down before today. Just be sure to work on catching up on your zeros. We do have the next day set for review, so tomorrow you do have 1 day to review. So you have at least 1 full class period. Wednesday we're going to look at a pre-test. Your test is Thursday. Again, what you want to make sure you do, especially if you're not caught up now, is make sure you get caught up before this test, because it becomes very difficult learning Chapter 5 while catching up on Chapter 4. I think some of you learned that last quarter. So again, work as hard as you can this week, even if it means coming in early, staying late. Some of you put a whole lot of work into the last week of the quarter, where if you just do a third of that now, you don't have to do it all at the end of the quarter. So if you just take some of that energy, apply it to this week to try to make sure all your zeros from Chapter 4 are taken care of, that all your low scores from Chapter 4 are taken care of. You don't have to come back to Chapter 4 again. Plus, it's another way to review for your test, and it should help you out. So other than that, good luck, and good job fighting through a tough unit, because this was a tough unit and there was a lot of good information in here.